So how does the whole thing work? Because I've worked a little bit with nerves. I don't know if you've heard, I've probably heard of nerves because you're in that space, right? They have a A-B partition. I'm guessing you must do something similar because these things can fail, right? You have a cellular connection that could drop like that, especially in the middle of the Atlantic, right? So how does the whole thing work?
Yeah, so I mean, it's done at two levels, right? So at the core of it, on this small ESP32, a sort of a fairly disruptive chip choice from a Chinese manufacturer. It's a really excellent chip. It like a dual core, 240 megahertz RISC CPU. You can get that for less than $2, and it has like Wi-Fi and Bluetooth built in. It's pretty awesome. But on a chip like that, at the core of it, you have like a real-time operating system, and we put our virtual machine on top of that, and then all the way up, including the virtual machine, we consider that the firmware of the device. And when we update that, we do what you described. Like you have like a multi-partition setup where you build up the new version in the partition you're not running, so that you only flip over to it once you've made sure that that you gotten all the way through the update. Right. This is like how Chrome OS works as well with like the update mechanisms. You're updating the copy that you're not running, so you can verify that it actually got the right update before you flip over to it in the sort of a sort of transactional style thing. So that's what we do as well. But for the applications that run on top of this, we just realized that we can actually allow you to install these applications without updating the firmware. So you can install new self-contained small applications and replace them as you go. And there, like we don't really need partitions. We just put these applications in Flash and find them sort of almost like in a file system. And so if you're installing version n+1 next to version n, we just allow you to say, I only want to flip over and use the newest version when I'm done with that install. And it doesn't have to be partitioned that way. So it's much more flexible. And this works because the applications are fully relocatable, so they can be stored anywhere in Flash. So we don't need to know where they end up. So we just move them and where it makes sense, and they're very small. So we can send like a new application to a fleet of 1,000 devices and just send like 30 kilobytes of optimized code to these devices. So we're sort of back in the object-oriented virtual machine world again here with building sort of a layer that sits on all these devices that turns these devices into, I would say, like small little serviceable, upgradable computers, right? Instead of being sort of hardwired microcontrollers that are difficult to interact with. And with that, what we built as a sort of a product is really a cloud-hosted API, a place where you, using gRPC, Google's RPC mechanism, you can go and interact with our APIs, and through that communicate and deploy code to all your devices, right? So you talk to an API, sort of high-level, well-structured, declarative API, and through that you get to control your entire fleet of devices, to the extent that you can even like push code to it and schedule jobs on them and tell it what to do over time and get the data back from them. So it's like a very high level IoT platform play, if you will, on the software side. It's pretty awesome.
So,